what time the charge amplitude decreases to 0.5 Q naught, whereas the amplitude of a charge oscillating in a circuit decreasing equation is given in the question. It's given as Q is equal Q naught e power minus RT divided by 2L, whereas the value of R is given as 1.5 ohm and the value of self-inductance L is given as 12 millihenry, and we know that the value of ln2 is 0.693. It's also given in the question, and the value of Q is given as Q naught 0.5, and for that we have to calculate the value of. So let us apply the values in the given expression. So it can be written as 0.5 times Q naught is equal Q naught times E minus R T divided by 2L. So here we can apply the values. Before that, we can rearrange the equation as 1 over 2 is equal e power minus RT divided by 2L by changing 0.5 as 1 over 2. Again, by taking ln on both sides, it can be written as ln 1 over 2 is equal minus RT divided by 2L. When we are taking the ln on both sides, it can be written as ln 1 over 2 is equal RT divided by 2L minus. For this minus, we can change this as ln 2, which is equal to RT divided by 2L. We have a value of R and L, so we can rearrange the equation for T as T is equal ln 2 times 2L divided by R. When we are applying all the values, we will get the time value of 11.09 millisecond. So the correct answer for this question is option B.